In today's lesson, we'll be learning how to determine the point of intersection through the method of substitution. Over here, we have the equation of two lines, y equals 3x plus 1 and y equals x plus 3. We want to figure out where they intersect. In our first step, we're going to isolate a variable in one of the equations. It doesn't matter which equation you choose. I'm choosing to start with the red equation, y equals 3x plus 1. You can see that y is already isolated. It's on the left side of the equal sign all by itself, so there's nothing we really need to do here. In our next step, we want to substitute equations into each other and isolate the other variable. What that means is we're going to be starting with the other equation which we have not used yet. We're going to be starting with y equals x plus 3. Now, this is where substitution is going to occur. Since we already know that y is equal to 3x plus 1, and we have the variable of y over here, we can replace that variable with just 3x plus 1. Everything else on the other side, x plus 3, stays exactly the same. Once we do that, we can identify like terms. 3x and x are like terms, while plus 1 and plus 3 are like terms. I want all my x's on the left side of the equation, which means I'm going to bring this over. And when I bring it over, it becomes the opposite. That becomes negative x. And I want all my numbers or constants on the other side of the equation. I want it on the right side. So that positive 1 now becomes negative 1, and this positive 3 stays exactly the same. We can simplify this. 3x minus x becomes 2x, and negative 1 plus 3 becomes 2. To isolate x, we need to divide both sides by 2. These 2's are going to cancel out. Therefore, x is equal to just 1. In our next step, we want to substitute the known variable into any of the equations and solve for the unknown variable. What that means is we can choose any of these two equations. I'm going to start with the red equation, y equals 3x plus 1. In our previous step, we discovered that x was equal to 1, so I'm going to substitute that into this equation, and I'm going to simplify. 3 times 1 is 3, and then 3 plus 1 is just 4. At this point, we think our point of intersection is positive 1 and positive 4, but we need to check to see if this is correct, and you can accomplish that with a left side, right side check. Let's take a look at our red equation. So on the left side of our equation, we have the variable of y. We already know that y is the number 4. On the right side of our equation, we have 3x plus 1. We already know that x is 1, so we're going to replace x with 1 in brackets. Afterwards, we're going to simplify this. 3 times 1 is 3, and then 3 plus 1 is 4. As you can see, the left side is equal to the right side, and that's good. We're going to do the exact same check with the blue equation. On the left side of the equation, we have the variable of y. We already know that is 4. On the right side of the equation, we have x plus 3. We know that x is 1. I'm going to put that in brackets. And 1 plus 3 is just 4. And as you can see, the left side of the equation is equal to the right side of the equation. So we can state a conclusion down here. Since the left side is equal to the right side, therefore the solution is indeed positive 1 and positive 4.